let's learn something about ratios and proportions. So, we've heard about ratios, we've heard about proportions. We see around a lot of things which are very related to ratios and proportions. Say that you take a pizza and it is actually divided into different fractions, right? So, how would we say that one person in a group of 5 people ate one piece? So, we say that the pizza was divided as 1:5 ratio per person, right? Other than dividing the pizza story, we have a different lot of uses for ratios and proportions. We have a different lot of interesting ratios such as golden ratios. Have you ever heard about golden ratios, which is approximately around a number 1.618? This is a ratio which is said to be found in nature a lot and which includes the proportion of the human body. So ratios and proportions are very interesting thing to learn about. So let's see what we have to do. So ratio. In simple words, ratio is a way of comparing two or more quantities or numbers. It tells us how much one thing there is compared to another. Ratios are often written as two numbers separated by a colon or as a fraction. So basically, what is ratio? So in simple ways, I am saying that there are 4 apples, okay, or anything, or 4 chocolates. Let's say 4 chocolates. And there are 2 people. So there are 2 people and 4 chocolates. So the ratio between the people and the chocolate is 2:4. That is, we could write it as 2/4, which can be simplified as 1/2. So we could say that the ratio between the people and the chocolate, this is people and this is chocolate. And we could say that the ratio between people and chocolate is what? 1:2. That is, one person will get 2 chocolates, right? If you're dividing it equally. So basically, ratios are just a way of comparing quantities. So we are using 2 numbers to compare 2 different quantities, right? Now, in a ratio, if I'm expressing it in the form A by B, just like written here, we'll say that A and B, this could be written as A:B. So this is the ratio between A and B. Now, say another example. We have a square of length, side length. Oh, this is not a square. Okay. This is the maximum square I can do. So this is a square of length 1, side length 1. And then I'm taking the square of it. 1 square is again 1. So I'm adding 1. So now double the side length. I get a square of side length 2. Now I'm again adding 2 to it. Now I get a square. This turns out to be a rectangle, but still we get a square of side length 4. Now, what is the ratio of side lengths of these squares? We could say that it's 1:2:4, right? So this way the ratios are used to compare between different quantities. Now, let's see some properties of ratios. First property of ratio is equality. Ratios are equal if they represent the same comparison or quantities. For example, 2:3 is equal to 4:6 because they both represent the same ratio 2:3. Just like we told about the chocolates before. We are saying that there are 4 chocolates for 2 people, right? It's same as saying there are 2 chocolates for 1 person, right? That's what is said here, that it's same to say that 2:3 and 4:6 are equal. Why? Because I'm just simplifying 4:6. That is 4/6. I simplify it, I get 2/3. So saying that there are 4 chocolates for 6 people and they're saying that 2 chocolates for 3 people, it's the same thing. Now, scaling. Ratios can be scaled up or down by multiplying or dividing both parts of the ratio by the same number. The ratio remains the same even after the scaling. Again, just what happened right before, we had 2 to 4. So the ratio was 2 is to 4. We could write it also as 2 by 4. Now we are scaling it down, right? We are dividing the denominator by 2 and the numerator by 2, right? So we divided the denominator by 2 and we divided the numerator by 2 and we get 1 by 2. So we are scaling the ratio down, or at the same time we could scale it up. Here we scaled it up, right? We had 2 is to 3 here, which means it's 2 by 3. Now we are scaling it up by a factor of 2. That is, we are multiplying both the numerator and the denominator by 2 and we get 4 by 6, which is the ratio 4 is to 6. See? So the ratios can be scaled up and down, that is, we can increase it by multiplying both denominator and the numerator, and we could decrease it by dividing the numerator and denominator by the same number. Now, moving on, simplifications. Ratios can be simplified by dividing both parts by the ratio of their greatest common divisor. This reduces the ratio to its simplest form. This is again what we did in the first thing, that is, we took, 4 chocolates for 2 people. We compared the ratio. We took what is the greatest common factor here. So 2 is the greatest common factor, right? Because 2 is 1 into 2 and 4, it's 2 into 2. So what is the greatest factor here? 2. We scaled it down by 2. We divided it by 2 on both sides and we got 1 is to 2. So this is the simplified form of the ratio 2 is to 4. Now, unit conversions. Ratios can be used for unit conversions. How do we do this? So let's see. We just says that 1 meter equals 100 centimeters, right? So meter to centimeter ratio is given as 1 is to 100, right? Now I am saying that I have 4 meters. So how many centimeters is this? Just like this, we scale it down, we scale it up. Here we take 4, we multiply here by 4. So it's 4 is to 400. So it's used for unit conversions, right? Okay, moving on. There are different types of ratios. So first type of ratio we are talking about is a compounded ratio. So what is a compounded ratio? So we have 2 ratios, say A is to B, and then we have another ratio which is C is to D. So what is A is to B? Let's give for example, A is to B means 2 is to 3, and C is to D is actually, what should we say? 4 is to 6, okay? So compounded ratio means 2 is to 3 and 4 is to 6 are 2 different ratios. Now we compound it, okay, make it together. Now we are saying that 8 is to 6 3s are 18 is the compounded ratio of 2 is to 3 and 4 is to 6. What did we do here? We just says that the compounded ratio of A is to B and C is to D is AC is to BD, right? Now duplicate ratio. What is duplicate ratio? We are just saying a number 5 is to 7, which is A is to B, okay? I'm giving A as 5, B as 7. Now the duplicate of the ratio A is to B means 25 is to 35 is the duplicate of, 25 is to 49 is the duplicate of 5 is to 7. What does it mean? A is to B, the duplicate of A is to B is A square is to B square. Got it? We double it. Now, triplicate ratio. So, we talked about duplicate ratio, which is when we square the ratios. Now, we are talking about triplicate ratios. So, A is to B is a number. Now, we triplicate it. That is, we multiply it itself 3 times. Say we have a ratio 1 is to 2, taking it simple. So what is the triplicate ratio of 1 is to 2? It's 1 is to 8. Let's take another triplicate ratio. So we have another number 2 is to 4. We triplicate it. So 8 is to 4 into 4 is 16, 16 into 4 is 64. This is the triplicate ratio of 2 is to 4. Now, subduplicate ratio. We talked about duplicate ratios, right? So when we were duplicating a ratio, we were actually squaring the number. So when we are subduplicating the ratio, we just take the square root of the number. So let's see. We take 2 is to 4. It's a ratio, right? Now, what is the subduplicate of the ratio? It's root 2 is to 2. How come? We take the root of 2 and we take the root of 4. What is the root of 4? It's 2. Okay? Now, subtriplicate ratio. Now, we talked about duplicate ratio, then we talked about subduplicate ratio, we talked about triplicate ratio, and now let's talk about subtriplicate ratio. So if duplicate ratio was squaring a number, subduplicate ratio was taking the square root of the number. And triplicate ratio was cubing the number, so subtriplicate ratio is actually taking the cube root of the number. So let's say we have a number 8 is to 9. What do we do here? We have to find the subtriplicate ratio of 8 is to 9. We take cube root of 8 is to cube root of 9. Cube root of 8 is 2 and we say we have cube root of 9. So this is the triplicate ratio of subtriplicate ratio of this number. So let's see. Now let's talk about the reciprocal of a ratio. So reciprocal of a ratio. So we have a ratio A is to B, right? So what is the reciprocal of that? Reciprocal means we just take 1 by that ratio, that is 1 by A into 1 by is to 1 by B. So what is the same as? Let's write it in the fractional form so that we could understand it better. So A raised to B means A by B, right? Now what are we doing when we are taking the reciprocal of it? We are just taking 1 by A divided by 1 by B, right? Now this is what? 1 by A into B by 1. We are just multiplying this, the reciprocal of this above here in case of fractional division. So we get B by A. That means B is to A. Seems like it doesn't make sense. Let's see here. We have 1 by A is to 1 by B, right? So we just cross multiply it. So we get B by 1 is to A by 1. This means that it's B is to A. Let's take an example. Let's take a ratio 4 is to 9. A ratio 4 is to 9. What is the reciprocal of it? Reciprocal of 4 is to 9. See, let's start with 1 by 4 is to 1 by 9. What does this mean? It's 9 is to 4. How did we get it? It's 1 by 4 divided by 1 by 9, which becomes 1 by 4 into 9 by 1. Again, we get 9 by 4. So this is what is called as the reciprocal of a ratio. Now, simplest or the standard form. The simplest form of the ratio is the ratio that cannot be further reduced or simplified. So earlier we were talking about chocolates and people, right? So it was 2 is to 4. Can it be simplified? It can be, because why? We have a common factor here. So when we are dividing it by the common factor, we get 1 is to 2. So this is the simplest form because this doesn't have a common factor other than 1 here. So the simplest form of the ratio is the ratio that cannot be further reduced or simplified. Now, let's talk about proportions right now. So, we just said that ratios are the relation between two numbers, right? Now, proportions are the relation between two ratios. So, the proportion states the equality of two fractions or the ratios. So, we could see here two ratios being taken. A is to B, which is equal to C is to D. Okay. Now, the one at the two extreme ends are called the extremes. It's very easy because of it's on the extreme ends, so we could call it as the extremes. And the one who are on the middle is called the means. So now, while we are writing it in the fractional form, A by B equals C by D. This is a proportion where A by B and C by D are two ratios. Now, A by B and C by D. So, B and C are called the means. These are the means, and A and D are called the extremes. Extremes. So, let's see some properties of proportions. First property of proportion. Proportions involve two ratios that are equal to each other. We just said that. If the ratios are equal, the quantities they represent are in proportion to each other. So, when do we say that a quantity is in proportion? When do we use the word in proportion? When two ratios we have, see if we have 1 by 2 of one ratio and we have 2 by 4 of another ratio, they are in proportion because they are technically same ratios, right? Now, scaling. Proportions can be scaled up or down by multiplying or dividing both parts of the ratio by the same number. So, we earlier took a ratio A by B and we scaled it down, right? Remember, taking 2 by 4 and we just doing it as 1 by 2, we scaled it down. We could also scale it up by multiplying it by any number, say 2, we could take it as 4 by 8. So, the same way the proportions can be scaled. Let's say there's a proportion saying that 1 by 2 equals 2 by 4. Now we're scaling it to the factor of 2. We just get the same thing. 2 by 4 equal to 4 by 8, right? So, scaling can be done both in proportions as well as in ratios. Now, cross multiplication. When given a proportion, we can find the missing term by cross multiplying. This means multiplying the numerator of one ratio by the denominator of the other ratio and setting the products equal to each other. So, if we are seeing the ratio same as 1 by 2 and 2 by 4, right? It's equal. Now we are multiplying it with each other. This is the beauty of proportions, which is 1 by 4 equals 2, 1 into 4 equals 2 into 2. What did we do here? We just took a ratio A by B, which is proportionate to the ratio C by D. Now when we multiply A into D, we get C into B. That is, when the product of extremes is equal to the product of means. So, now we get the property of cross multiplication of proportions. Now, let's see what direct proportions are. Direct proportion is a relationship between two variables when they change in same direction. This means that when one variable increases, the other variable also increases, and one variable decreases, the other variable also decreases. So what does this mean? Let's say I am selling apples, and when I'm selling apples, I get money. So the more amount of apples I sell, the more money I get. So the ratio of selling of apples and gaining of money is in direct proportions, which is if one of them is increasing, the other one would also increase. Say, let's say another thing. So what increases when one thing increases? Okay, you're studying a lot for an exam. Okay, so when you study a lot for an exam, the exam become easier, right? So the amount or the quantity or whatever, the more time you study, the more easier the exam becomes. So it is in direct proportions. When one quantity increases and the other quantity also increases accordingly. Now, we have inverse proportions. Now what are these? Inverse proportions is a relationship between two variables where they change in opposite direction. This means that when one variable increases, the other variable decreases. Now what do we use this inverse proportions for? Say, we have a car here. Let's name this square box as a car. Consider this as a car. And we have a road here. So now the car is moving, right? The car is moving on the road, and when the speed increases, the time which is taken to reach, I want to reach here. This is the place I want to reach. So when the car increases its speed, the time which it takes to reach this place decreases, right? So when the speed, one quantity is increasing, the time, the other quantity is decreasing. So this inverse relationship of increasing and decreasing is known as inverse proportions. So this is all about ratios and proportions. Let's just quickly go through a summary. We started with ratios, we talked about what ratios are. We said that ratios is a comparison between two numbers, two whole numbers, two quantities. We could compare two quantities using ratios. Now, we told about the properties of ratios, we told about equality, we told about scaling, we talked about simplification, and then we talked about the use of a ratio, which is a unit conversion. And now then we talked about the types of ratios. We had compound ratios, where if A is to B and C is to D is a ratio, then the compound of the ratio is AC is to BD. Now the duplicate of the ratio A is to B equal to A square is to B square. Now the triplicate of the ratio A is to B is A cube is to B cube, and the subduplicate ratio of A is to B is root A is to root B. Now the subtriplicate ratio of A is to B is A cube root of A and cube root of B. Now reciprocal of a ratio A is to B is B is to A. How does that come? 1 by A is to 1 by B. When we cross multiply it, we get B is to A. Now, the simplest or the standard form of the ratio is the most reduced form of the ratio. That means that it doesn't have no common multiple. Now, moving on to proportions, we take equal ratios, we call it proportions. We comparing ratios is proportions, whereas comparing quantities is ratio. Now we talked about properties of proportions, we had equality, we had scaling, and then we talked about a much important property, which is cross multiplication. That is, when we take the product of extremes, we get the product of means. And then we talked about direct proportions, which are the proportions when one quantity increases, the other quantity also increases. These are called direct proportions. And when one quantity increases, the next one decreases, or vice versa, is called as inverse proportions. So this is all about ratios and proportions.